This vitamin D story is full of surprises. I'm going to walk you through a number of analyses on how vitamin D supplementation affects your bone health, and I think you'll be a little surprised by the results. To start, since this is Physionic and since the mystery begins in how vitamin D interacts with our bones, let's come to some understanding of the mechanisms before we get to the clinical data. For that, we can lean on these two scientific reviews. Herein, the researchers point out the fascinating and complex mechanisms by which vitamin D affects our bones. So, buckle up. Vitamin D can act directly on your bone cells through a binding of a nuclear receptor, meaning a receptor found in the cells that, once bound, will move to the nucleus of your cells, where your DNA of your cells is kept. Here, the vitamin D receptor controls the gene reading known as transcription of calcium metabolism, bone remodeling, bone mineralization, and more. The vitamin D receptor not only directly binds these genes to encourage or discourage their reading to make the responsible proteins, but it can influence other signaling proteins called co-activators and co-repressors to bind these genes to allow or disallow the production of those bone remodeling proteins. The amount of vitamin D, calcium, and bone regulating hormones in the blood influence if vitamin D receptor is active or not. So we've discussed generically how the vitamin D receptor works, but more specifically, it can influence stem cells in your bones to turn into different bone cells. Your bone cells are split into three camps: osteoclasts, osteoblasts, and osteocytes. We'll focus on the first two, and I'll even explain what they do too. So osteoclasts are known for being bone resorption cells, meaning that they degrade at the bone material that's already present. If you're thinking, well, shouldn't we stop these cells? The answer is, well, yes and no. Yes, as in we don't want them to be overactive, but no, because our bones need to be remodeled continuously. And osteoclasts carry out that key function for optimal bone health as they destroy less than optimal organization of the bone structure. On the flip side, osteoblasts are the bone building cells. These cells deposit bone material like extracellular matrix, hydroxyapatite, and other protein, calcium, and phosphate structures that give material and strength to the bone. Okay, vitamin D receptors are heavily found on stem cells that can be convinced to become osteoblasts. When vitamin D binds, these stem cells begin producing osteoblast differentiation proteins. These are proteins that convince the cell to become a bone cell, like RUNX2, Osterix, and alkaline phosphatase. Not only that, vitamin D receptor, when bound by vitamin D, can encourage osteoblasts, those are the bone building cells, to produce more bone-related proteins for bone mineralization, bone production. That's a lot. But we're actually going to go a layer deeper because so far everything seems to fall in line with, well, generally how we think about vitamin D in bone. But I'm about to introduce a wrench into the picture. Vitamin D receptors can also influence the production of two key proteins in osteoblasts, RANKL and OPG. RANKL is an osteoclastogenic factor, which means that it activates the bone-destroying osteoclasts. Vitamin D receptors known to inhibit the production of RANKL in osteoblasts, which would otherwise be produced and bind the osteoclasts on their membrane-bound RANK protein. When RANKL on osteoblasts and RANK on osteoclasts interact, it triggers immature osteoclasts to turn into mature osteoclasts and begin destroying bone. The active vitamin D receptor stops that from happening by reducing RANKL production, but also by encouraging the production of OPG, which binds RANKL itself, blocking RANK on osteoclasts from interacting. The short of it is, vitamin D receptor encourages bone building and reduces bone destruction. Now, what if I told you that the vitamin D receptor is also known to do the exact opposite? Namely, that it increases rank L and reduces OPG, with the overall effect of reducing osteoblast activity and increasing osteoclast activity. Well, that's what this review points out. So think to yourself, how can the same molecule, vitamin D, increase bone production and yet also decrease bone production using the exact same mechanism? There is an answer, and we'll get to it. First, let me mention that the mechanisms that I just went over are actually only a few. There's many others, like vitamin D affecting calcium absorption or the effect on the parathyroid, but I focused on the direct effects. Second, I'd like to get into the clinical data because there's some mysteries here too, but don't worry, I promise we will get some solid answers. Okay, let's start here. In this analysis, the researchers compiled data from 23 randomized controlled trials. I really like several aspects of this analysis because they included a majority of studies that used an inert placebo as the comparison against vitamin D. They also limited the analysis to include only studies that lasted a minimum of 6 months, which is important when measuring such a slow-growing system like the skeletal system. If we look at the data, here, we're looking at bone density in the lumbar spine. Note the studies are listed on the left side, and the deltas, or the difference between the control and the vitamin D supplemented people, are on the right. However, we can ignore that and look at the squares. These are the results of each study as well. If they fall on the 0 line, there's no benefit of vitamin D supplementation on bone density. If they fall to the right, there is a benefit. Clearly, some move to the right and some move to the left, leaving us, well, equally confused. So, to simplify, you can focus on the diamond at the bottom, which is the total effect, all studies accounted for. If you're thinking to yourself, there doesn't really seem to be an effect, you're exactly right. There's no effect of vitamin D supplementation on bone. In fact, across multiple other measures, these results remain the case. However, it wasn't universally the case. When measuring the femoral neck, vitamin D supplementation did offer a benefit. Still, the majority of the measures indicated no effect. There's several reasons why. We'll get into that. First, allow me to introduce you to one more analysis, and this analysis tells a vastly different story, because the majority of the measures here, which are identical to the ones used in the previous analysis, like femoral neck, spine bone density, indicate an effect of vitamin D. We see that exemplified here. The rules on how to read this are identical to before. The studies are just an ugly neon green. We can see the overall effects diamond move to the right and confirm statistically that vitamin D supplementation provides benefit to lumbar spine bone density, the same measure that squarely was not showing an effect in the previous analysis. So why the discrepancy? I know some are going to jump to funding of the studies and conflicts of interest, so I looked into both of those analyses, and both were independent of industry funding, and the only researcher with ties to industry was involved in the analysis, indicating vitamin D was effective. So we should look for other key differences between these analyses. For one, the second, the more favorable analysis, included more studies, 13 more studies in fact. However, the inclusion criteria standard for which studies would be included was set lower, meaning that they included more studies that were not placebo-blinded, which means the analysis might have more data to detect effects, but it is also more burdened with the potential bias. However, they also included only studies using vitamin D3, which is believed to be more potent than D2. The first analysis included both, which would muddy the waters. So, it's quite a pickle that we're in. Fortunately, there are still some ways of getting the answer. By the way, I also looked at vitamin D on bone fracture risk, and I'm going to be going over more vitamin D bone mechanisms in the extended version of this video. If you're interested, just join the Physionic Insiders. I'll also be going over specific unaffiliated product recommendations that are independently tested for quality. I try to cover it all for the insiders, so consider joining. The link is in the description. Okay, let's get some answers to all of it. If we group all these data together, a few things stand out. One, both analyses indicate that effectiveness of vitamin D supplementation is most robust in people who are deficient. Both groups of researchers show data that in these people there is a benefit. The second analysis pointed out 4 things that determine effectiveness. 1, consistent use. 2, baseline vitamin D levels, so deficiency that we just went over. 3, vitamin D levels at the end of the study, so were people no longer deficient. And 4, sex. Women experienced greater benefit than men. And although not as readily agreed upon by the second analysis, the first analysis indicates that older individuals over the age of 65 experienced the greatest benefit to their bones from vitamin D supplementation. So, all considered, it seems vitamin D supplementation has more evidence in its favor than against, but there's some nuances here that we need to discuss. Remember when we went over how vitamin D increases and decreases the activation of the osteoclast through the same mechanism? Well, the researchers of this more conservative analysis propose there is a biphasic response of vitamin D, meaning there are 2 bodily reactions to vitamin D. 1 when vitamin D is too low, and 1 when vitamin D is too high. They argue that having too low vitamin D levels leads to greater bone resorption, so greater osteoclast activity. Then normal levels allow the appropriate balance of osteoblast activity for bone building and maintenance. And then very high vitamin D levels again lead to greater osteoclast activity, bone resorption. So the dose is the cure and the poison, which means that supplementation should be done carefully. In fact, they point out that vitamin D shots, where people take up to 100,000 IUs at once or more of vitamin D in one go, or even if they consume large amounts on a daily basis, can have unintended bone weakening effects because of this vitamin D paradoxical effect on the bone cells that we discussed. Actually, there's more to be said on that front when looking at bone fractures, assuming that you're watching the extended version. So, where does that leave us, everything considered? Here are the takeaways. Vitamin D supplementation is a yes for those who are deficient. It's likely a benefit for people over the age of 65. However, if your blood vitamin D levels are normal and you're under 65, the supplementation of vitamin D is probably not necessary. However, assuming a person did want to supplement, most studies, including those indicating effectiveness, use modest doses between 400 and 800 IU of D3. Possibly slightly higher for those over 65. Also, keep in mind that we're assessing bone health, so this does not extend to other benefits of vitamin D. Anyway, want more of this kind of investigation of the science? Well, then check out this next video. Thanks for tuning in.